So let's again start with the last question of this exercise 8.1 that we are continuing from the 3 to 4 lectures, right? So in this lecture we will solve the last question of that exercise, that is question number 12. Okay, so let us understand the question. According to the question, ABCD is a trapezium. So as you can see, this figure ABCD is a trapezium. And what is a trapezium? A trapezium is a quadrilateral in which only one pair of opposite sides is parallel. So in this case, it is already given that AB parallel to CD. That means this side is parallel to this side. And AD is equal to BC. AD and BC are two non-parallel sides. They are non-parallels. Okay. And it is given that the length of AD is equal to the length of BC. Already I have told you, if in a trapezium the non-parallel sides are equal, then it is known as isosceles trapezium. So ultimately this trapezium is an isosceles trapezium, and in this trapezium AB parallel to CD and AD is equal to BC. This is already given. Now from the following data we have to prove here 4 statements. Okay. So without any wasting much time, let us start proving the first statement that A is equal to B. Okay, in the first statement we have to prove that this angle is equal to this angle. Okay, so already in your textbook a hint is given. A hint is already given. What is the hint? The hint is, in order to prove such things, we have to do what? We have to just extend the line or the side AB to a point E. We have to do what? We have to extend the side AB to a point E, okay, to a point E, and join E and C such that AD parallel to CE. Understood? So what we have constructed here? What we have constructed? So construction, we have extended the side AB to a point E, right? So extend AB to E, and then what we will do? Then we have to join C and E, and join C and E such that, right, such that AD must be parallel to C. Okay, such that AD must be parallel to C. Clear? So this is construction, it is already given in your book, right? So now let us prove the first statement. Proof of the first. Since we are going to prove that this angle is equal to this angle, okay, let us first understand another thing. See, already it is given that this line is parallel to this line. Okay. If this line is parallel to this line, then we can say that this total line is parallel to the total line. Yes. Okay. So as we know that total line AE is parallel to this DC. Clear? Because it is already given. Since it is a trapezium, so if parallel to CD, it means the total line A is parallel to CD. Done. And we have constructed that this side AD must be parallel to this side EC or CE, and AD parallel to CE. Clear? So here what we have found? We have found in the quadrilateral AECD. Which quadrilateral? AECD. So in this quadrilateral, AE is parallel to DC and AD is parallel to EC. It means the pair of opposite sides are parallel. Hence, this quadrilateral is a parallelogram. Clear? So you can write hence ADCE is a parallelogram. We can write it short formally. Okay. Either we can write parallelogram or you can simply write parallelogram. Okay. So now ADCE is a parallelogram. So since it is a parallelogram, then its pair of opposite side must be equal. Okay. So implies we can write Since ADC is a parallelogram, so you can write that AD must be equal to EC. Yes, we can write because they are pair of opposite sides. AD is equal to CE. Is it clear? Okay, but already it is given that AD is equal to BC. Already we know this side is equal to this side. But here we know, or here we have proved that AD is equal to CE. We already know this AD is equal to BC. Now we have proved AD is equal to EC. It means this side must be equal to this side. Okay. So AD is equal to CE is equal to AD is equal to what? BC. Is it clear? AD is equal to BC. Okay. So simply you can write if this is equal to this and this is equal to this, it means this is equal to this. BC is equal to CE. So we can subtract or we can extract. We can extract BC is equal to C. BC is equal to C. It means this side is equal to this side. Clear? Okay. Let's say this is our equation number 1. Okay. It is very important but very easy to understand. Okay. First of all, we have extended the side so that a parallelogram is formed. This side parallel to this side parallel to this side. Here. Since it is a parallelogram, then the pair of opposite side must be equal. So AD is equal to CE, but we already know AD is equal to BC. So BC must be equal to EC. Right. Next, if we consider the triangle BCE, and in this triangle, as you can see, BC side is equal to EC side. If any two sides are equal, then definitely their opposite angles must be equal. Right. So for triangle BCE, this side is equal to this side. It means their opposite angles must be equal. Okay. So suppose this angle is known as CBE. So you can write CBE angle is equal to this angle CEB angle. Is it clear? Okay, don't be confused. So it is due to opposite angle of equal side. Opposite angles of equal sides. Clear? These are the opposite angles of equal sides. So we have proved that this angle is equal to this angle. Okay. So now we will erase it and understand another concept. Okay. So here we have proved that this angle is equal to this angle. Right. Next. Wait. So now, as you can see that ADCE is a parallelogram. Okay. So this angle A and this angle E are two consecutive angles. Right. So if we consider ADC as a parallelogram, then this angle and this angle are two consecutive angle, and we know the sum of two consecutive angle is 180 degree. So here we can write that angle A plus angle E, okay, is equal to 180 degree. Why? Because they are consecutive angles. Clear? Let's say this is equation 1. Equation 1. Okay. Now, since we have already proved that this angle E is equal to this angle, clear? We have proved that this angle is equal to this angle. Clear? So in the place of angle E, we can substitute CBE. Clear? So you can substitute angle A plus, in the place of angle you can substitute CBE is equal to 180 degree. You can write the reason here. Okay, you can write the reason that this angle is equal to this angle. Since CEB is equal to CBE. Okay. Let us take this one as equation 1. This one as equation 1. Okay. Then, as you can see, AE is a straight line. and BC is a ray which stands on this straight line A. Then this angle and this angle are known as which type of angle? They are known as linear pair angles. Okay. So as we know, the sum of two linear pair angle is 180 degrees. So we can write that this angle means angle B, or you can write ABC angle. Okay. So angle B plus this angle CBE is equal to 180 degree. So we can write, and angle B plus CBE, this angle CBE is equal to 180 degree. Why? Because they are linear pair angles. Here, suppose this is our equation number 2. Equation number 2. Now look at the two equation 1 and equation 2, and in this two equation their right hand side are equal, that is 180 degree and 180 degree. So if in two equation two right angles are equals, or two right hand sides are equals, then their left hand side must be equals. Okay, so we can write that the left hand side of equation 1 must be equal to the left hand side of equation 2. So from equation 1 and 2 we get the left hand side angle A plus CBE is equal to angle B plus CBE of the equation number 2. Okay, so now we will do take this CB to the left hand side. Okay, so in the left hand side already we have A plus CBE, and when this CBE move to the left hand side, then it will be minus of CBE, and in the right hand side we have angle B. Now this CBE can be cancelled out, and the final result that we get is angle A is equal to angle B. Okay, so this is the final result that we have got. That is the angle A, this angle is equal to angle B, this angle. Okay, and we also need to prove this statement that angle A of the trapezium is equal to angle B, and here we have it. Okay, so now we will prove the second statement that angle C is equal to angle D. It means this angle C is equal to this angle D. We will prove this. Okay, so let us start proving the second statement. Since in the given data it is already given that for this trapezium ABCD, AB side is parallel to CD side. It is given. AB side is parallel to CD side. This parallel to this. So we have, since AB parallel to CD. Okay. So if AB parallel to CD, and if we consider AD is a transversal line, okay, AB parallel to CD, AB is a transversal line, then these two angles are which type of angle? What is the relationship between them? They are known as co-interior angle. And we know the sum of any two co-interior angles is equal to 180 degree. So we can write that angle A plus angle D, is equal to 180 degree, as they are co-interior. Clear? Similarly, if we consider the same two sides, AB parallel to CD and BC is a transversal line, then this angle and this angle are also co-interior, and this sum of these two co-interior angle is also 180 degree. So we can write, and angle B plus angle C is equal to 180 degree. It is also due to they are co-interior. Okay, suppose this is equation number 1, and this is equation number 2, Now just look at the two equations. Their right hand side must be equal or are equal. If their right hand side equal, then we can write that their left hand side must be equal. So from equation 1 and 2, we get their left hand side A plus D is equal to B plus C. Their left hand side are equal. Okay, and now we can write angle A plus angle D. Now this B can be moved to the left hand side, so that it will be minus B is equal to what? Is equal to C. Okay, So now angle A plus angle D minus, in the place of angle B we can substitute angle A. The reason is already we know the angle A is equal to angle B. Okay, already we know or already we have proved. So in the place of angle B we can substitute angle A is equal to angle C. Reason is angle B is equal to angle A. And now these two angles can be cancelled out. So finally what we have? And finally we have angle D is equal to angle C. This is the final result. So we have proved that angle D, this angle, is equal to angle C, this angle, and here it is. We have to also prove this thing. Angle C is equal to angle D, angle C is equal to angle D. This is proof number 2, right? So next we will prove the third statement. Okay, so let's move to the next page. And now moving to the proof of the third statement. In the third statement we have to prove that the triangle ABC, which triangle? ABC triangle. In order to draw a triangle ABC we have to join this so that a triangle is formed. ABC triangle is congruent to the triangle BAD. BAD, this triangle. So that we have to join the line BD or the diagonal BD so that BAD triangle is formed. So ultimately we have to prove the triangle ABC is congruent to the triangle BAD. Okay. So in order to prove these two triangles are congruent, we have to compare them. So between triangle we can write between triangle ABC and triangle BAD. Find the possible three conditions so that they will be congruent. The first condition is that for triangle ABC, AB is a side, and for triangle BAD, AB is also a side. So AB is the common side to both the triangle. Common side. Second possible condition is that for the triangle ABC, this triangle, B is an angle. For the triangle BAD, A is an angle. Yes or no? But we have already proved in the statement number 1 that these two angles A and B are equal. So these two are equal. We already proved it. Okay. So you can write by proved. The third condition is for triangle ABC, this triangle BC is a side. For the triangle BAD, AD is a side. And already we have AD is equal to BC. AD is equal to BC. So you can write AD is equal to BC because it is given. So by side, angle, side. Okay. Side, angle, side criterion, we can write triangle ABC is now become congruent to the triangle BAD. Understood? So this triangle ABC is now become congruent to the triangle BAD. This is the proof of third statement. So proved third statement. Is it clear? Next we will prove the fourth number statement. Fourth number statement. That AC means the diagonal AC for the trapezium ABCD is equal to the BD. BD is also diagonal, so we have to prove that two diagonal AC and BD are equal for this trapezium. How? Since already we have proved that the triangle ABC is congruent to the triangle BAD, we have already proved. So we can write since triangle ABC is congruent to the triangle BAD. We have proved it. Now for triangle ABC, AC is a side, right? And for triangle BAD, this triangle, BD is a side. Since already we know these two triangles are now congruent, if any two triangles are congruent, then their corresponding sides must be equal by CPCT. So now we have proved the diagonal AC is equal to the diagonal BD, and now it is proved. Proof number 4. Clear? So today we have completed all the questions from the exercise number 8.1. After this lecture, we will solve or we will move to the another concept, 4 theorems. Okay, then after exercise number 8.2, and we will finish the chapter number 8. Right.